Hey guys, today I'm going to teach you how to find distance on a coordinate plane. By the end of this lesson, you'll be able to create right triangles and apply the Pythagorean theorem to find diagonal distances on a coordinate plane. So go ahead and get out your binder, turn to the math section. Let's get ready to take some notes. All right, so distance on a coordinate plane is actually another application of the Pythagorean theorem. Before we get into that, let's look at a simple example of finding distance between 2 points on a coordinate plane in graph A. In this example, you can just count the number of units between the 2 points. So in this case, it's 1, 2, 3 units long. It's easy to count whenever the distance is horizontal or vertical. However, in graph B, you see a diagonal distance. This is not countable. You can't just go, okay, this is kind of like 1, 2, 3, 4. It's not like that. Instead, what we can do is be really strategic, and we can create our own right triangle on the coordinate plane and use the Pythagorean theorem to calculate the distance. Let me show you what I mean in graph B. We want to create a right triangle. And since what I'm looking at is a diagonal, I know that this is going to be the length of a hypotenuse. So I'm going to build the legs, and it's almost like how you would count slope. I know I go down 3 and over 4 to get from point to point. You can count those distances vertically and horizontally. This is 3 units and this is 4 units. So now I can use the Pythagorean theorem to solve for this diagonal. When I plug in my values, I know 3 squared plus 4 squared equals c squared. I need to simplify. So I get that 25 equals c squared, and I want to take the square root of both sides to get what c equals. So in this case, the diagonal distance is 5 units. The diagonal distance will always represent the hypotenuse, or the c value. So anytime you want to find diagonal distance on a coordinate plane, you can always build a right triangle. Let me show you another example with number 1 below. I want to use the Pythagorean theorem to find the distance between points A and B on the graph. So the first thing I want to do is connect point A and point B. That is going to be a diagonal line, and so I know that's going to represent my hypotenuse when I build my right triangle. So now I need to build my right triangle. And again, this is just like how you would calculate slope. You kind of need to like count your rise over your run. So I go up and over to make this a right triangle. Now that I've built this right triangle, I can count the distance between C and B and A and C because those are up and down and side to side. I know that this is 4 units and this is 5 units, literally just by counting the number of units between C and B and A and C. Since these two side lengths made my right angle, they're my legs. And when I use the Pythagorean theorem, I'm going to plug those values in for A and B. Then I need to simplify. I know 25 plus 16 is 41, and that is what c squared is. Since I want to know what just c is, I'm going to take the square root of both sides. So the distance between A and B represents the square root of 41, or approximately 6.4 units. So go ahead and try number 2 by yourself, doing the same thing I just did for number 1. Pause the video now to try it and press play when you're ready to check. All right, so the first thing you should have done is drawn your line to connect A and B. That's going to make a diagonal. Now, I want to point out now that there are 2 different ways you could solve this problem. You can make a right triangle that looks like this, or you can make a right triangle that looks like this. It doesn't matter which way you do it, you're going to get the same answer. Because either way you draw your triangle, it'll have a width of 2 and a height of 7. Then you want to substitute those values into the Pythagorean theorem. 2 squared plus 7 squared equals c squared. Simplify, and then use the inverse operation for squared, which is to take the square root to get an approximate value for the distance between A and B, which is the square root of 53, or approximately 7.3 units. At this point, I would take a step back and just check that the distance between A and B, the hypotenuse, is the longest side of the triangle. Since it's 7.3 and that's bigger than 7, that's at least one helpful clue that I did this correctly. Now try number 3 by yourself and press play when you're ready to check the whole thing. All right, so using the same process, I drew my diagonal, created a right triangle. I counted the units that create the legs and plugged them into the Pythagorean theorem. When I got the sum of the legs squared, 128, I took the square root of that number to get approximately 11.3 units. That means that the distance between A and B is approximately 11.3 units long. And again, that makes sense because that is the longest side. All right, so in 4 through 6, we're going to do the same thing that we just did, except it's a little more difficult. We have to plot the points and then create our right triangle and find the distance between it. So let me help you get started on number 4. The first thing we need to know about points is that they're written x, comma, y. I always think you walk before you fly. It also might help to label this is the x-axis and this is the y-axis. And we will always plot points in that order. So the first point is at -6, so I'm going to find -6 on the x line. So the horizontal line, -6 is here, and I go up 1 on the y-axis. So my first point is here. I'm going to do the same thing to plot my next point. I'm going to go over -4 on the x-axis, so here, and then 5 is on the y-axis. That means go up 5. So at -4, I count up to the 5, and then I plot that point. I'm looking for the distance between those 2 points, so I'm going to connect them, and then I'm going to build a right triangle. When I do that, I realize that I have 2 legs with lengths of 2 and 4, so I can use the Pythagorean theorem to solve for my missing length, c. So I want to start by plugging in my values. Since 2 and 4 make the right angle, they're the legs, so they're a and b. So I want to plug in my values and simplify. I know that c squared equals 20, but I want to know what c equals. So I need to take the square root of both sides. The square root of 20 represents the distance c between those 2 points, which you can simplify and approximate to be about 4.5 units. So take a second to try number 5 and number 6 by yourself. Pause the video now to do that and press play when you're ready to check. All right, so here is my right triangle for number 5. I found an approximate distance of 11.7 units, and here's my right triangle for number 6. There's an approximate distance between those 2 points of 8.6 units. All right, so number 7 and number 8 are just going to take this to the next level. Perimeter means add up the lengths of all the sides. It's easy to find the lengths of these sides, but you're going to need to use the Pythagorean theorem and build a right triangle to find the distance between the 2 points that make diagonal lines. So I'll give you a hint. Your right triangle is going to be here for number 7 and here for number 8. So take a second and try these 2 challenge problems by yourself and press play when you're ready to check. All right, so here's number 7 and number 8. It's easy to count these vertical and horizontal lines, but when you have a diagonal, you'll need to build a right triangle and solve for the hypotenuse. Just remember that in 7 and 8, the question was asking you to find the perimeter. So always pay attention to what the question's asking you. Another thing you might have started to recognize are these Pythagorean triples. 6, 8, and 10 are whole numbers that can make side lengths for a right triangle. Same for 4, 3, and 5. Those are Pythagorean triples you should memorize. All right, so last question. Let's look at number 9. It says, in the graph below, point A represents Ashley's house, point B represents Bridget's house, and point C represents Carly's house. Each unit on the graph represents 2 miles. That's going to be really important later on. To the nearest tenth, how many miles is Ashley's house from Bridget's house? See if you can figure out part A by yourself. Pause the video and press play when you're ready to check. All right, so I started by drawing my line, and then I'm going to create the right triangle. That right triangle will have legs of 5 and 11, so I'm going to use the Pythagorean theorem to solve for my missing hypotenuse, or c. So 5 squared plus 11 squared equals c squared. Then I'm going to simplify. I know 146 equals c squared, but I want to know just what c is. That's the distance between A and B. So I'm going to take the square root of 146 to get approximately 12.08 units. But since each unit on the graph represents 2 miles, I need to multiply this number by 2. So the distance between Ashley's and Bridget's houses is about 24.2 miles. Part B says to the nearest tenth, how many miles is Ashley's house from Carly's house? Take a second, pause the video to try that by yourself, and then press play when you're ready to check. So I'm going to build a new right triangle with legs of 2 and 10, and I'm going to plug those values into the Pythagorean theorem for A and B. Now I'm going to simplify. I know 102 equals c squared. I want to know what just c equals. That's the distance between A and C. So I'm going to take the square root of both sides. When I do that, I get about 10.19 units. However, each unit on the graph represents 2 miles, so I need to double this number. That means that the distance between Ashley's house and Carly's house is approximately 20.4 miles. Part C says, whose house does Ashley live the closest to and by how many miles? We can see that Ashley lives closer to Carly because the distance between those 2 points is smaller or shorter than the distance between Ashley and Bridget's house, which is 24.2 miles. So we know Ashley lives closest to Carly by 3.8 miles, and I got that number by subtracting the distance from Ashley's to Bridget's from Ashley's to Carly's. All right, guys, that's it. If you made it to the end of this video, please put in the comments a summary of what you learned in this lesson. Today, we learned all about distance on a coordinate plane, so now you should be able to create right triangles and apply the Pythagorean theorem to find diagonal distances on a coordinate plane. So go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!